This is a video for AQA Discrete Mathematics, Binary Operations, Section 2.1, Introduction to Groups. Well, we start by defining what we mean by a group, and that is simply a set of elements G together with a binary operation. Now, the idea of a set is familiar, and you should already have met the idea of binary operations. Those two things then have to satisfy a set of rules. We call the group axioms, of which there are 4. The first of these is that the group is closed. In other words, if we combine using the operation, which is usually indicated by a circle, or maybe some people call it a blob, or perhaps a star might be used. But whatever we're using as the symbol, any two elements that are combined must be in G. So we could say that for all A and B, then A circle B is an element of G. So closure is the first of the group axioms. The second one is it's associative. Now remember that associativity is where we can place brackets in different situations and get the same answer. So here we've got that A combined with B and then secondly combined with C. It's the same as doing B and C first and then combining that with A. So the bracket can go in any position. So the group has to be closed and associative. There has to be a unique identity element. Now, an identity element is one really where if we combine it with any element, then it doesn't affect that element. So we can write that in a statement as E combined with A is equal to A combined with E equals A. And that's true for every single element of the group G. And finally, each element must have an inverse. Now the inverse is the element which combined with A produces the identity. So we have that A combined with the inverse of A must be equal to the inverse combined with A. Notice that the order there has to be in both orders to give the identity element E. So you need to be familiar with these axioms for a group: closure, associativity, identity, and inverse. Notice that for a group you do not need to have the other type of property that you may have met before, which is A, B being equal to B, A. In other words, that for a group, the elements do not have to be able to combine in the opposite order to produce the same thing. In other words, it does not necessarily have to be commutative. Well, make sure you get familiar with these properties, because if you are to show that a particular set combined with a binary operation is indeed a group, then it's these properties that you need to show hold for that set. So here's an example then where we've got the set which is 1, -1, I and -I, where I is square root of -1, and we're looking at the operation being complex number multiplication. Well, one way to go about checking whether this is a group or not is first of all to produce a Cayley table. This is something you've seen in previous videos, and on our Cayley table we can write in the values that we get when the multiplication, so 1, -1, I and -I on the top row. If we multiply by -1, then -1, -1 multiplied by 1 is 1, -I, and then negative and 1 multiplied by -I gives -1 multiplied by -1, which is +1 times I. and so on. I, negative I squared of course is negative 1, and then negative I squared is going to be plus 1, and finally negative I, 1 and minus 1. So that's our Cayley table showing all the possible outcomes of the elements being combined with each other using complex number multiplication. Now if we're going to check that this is a group, we have to check each of the properties. So we need to check the fact that it's closed, associative, the fact that there is an identity, and then check for inverses for each element. So is it closed? Well, we can see immediately from the Cayley table that all of the elements within the table here are elements of the set, and so yes, it is definitely closed. Is it associative? Well, what we need to do here is to check for each element that we can put that bracket in a different place. So for example, we could look at I combined with, so using multiplication, negative 1, and then combined with negative I. And if you do that, then the first bracket produces negative I, so we've got negative I multiplied by negative I, which is negative 1. If we look at it in the other order, then we can look at I multiplied by negative 1 multiplied by negative I, and this time we get I, and the bracket produces I as well, so that's I squared, which again is negative 1. So it's true for those. We'd have to check it for all, but you can do that, and you can see that it is indeed an associative operation on that particular set. Is there an identity element that's unique? Well, what we need to do here is to check, is there a value that produces a multiplication which is identical to the elements in the top row of the table. It is there, so we've got 1, negative 1, I and negative I, and also if we look at 1, it produces in the other order no change in the elements. So yes, we can see that 1 is equal to the identity element E. And finally then we need to check the idea of an inverse. So that means that we need to have for all values that A, B, remember A combined with B is equal to the element E, so we need to check for every element that there is a value which gives us E. And so for 1, well, it's 1 itself, negative 1 produces 1, and then for I, got negative I, and for negative I. So as it satisfies all of the axioms, then this is a group. That completes this video just as an introduction to groups, and in the next one we'll be looking at how we do some working with groups.